In this video, we're going to talk about 7.08 division of polynomials. We know that a division problem can be represented as a fraction. In this case, we're looking at 21 as our numerator, 7 as our denominator. In other words, 21 is our dividend and 7 is our divisor. And what is the quotient of 21 and 7? That just means 21 divided by 7, which is equal to 3. With polynomials, let's look at some rules that we're going to be applying. Here we have two different problems. We have 21 plus 21 divided by 7. Well, if we were to follow order of operations, we know that we would get 42 divided by 7, which is 6. Let's look at what we're going to have to do with polynomials because we're going to have things that are not like terms. Another rule that we'll be applying is that if we have a binomial divided by a monomial, like 7, so if we have two things that we're adding, we can divide as long as we divide both things by 7. So if I divide 21 by 7, I get 3. Well, as long as I divide this 21 by 7 and get 3 and add the 3 plus 3, I'll still get that answer of 6 that we know we should get. So again, let's look at that a little closer. 21 plus 21 divided by 7 is the same thing as 21 divided by 7 plus 21 divided by 7. I have to make sure I divide every term by 7. How is this last problem different? 7 times 7 divided by 7? Well, let's think it through with order of operations first. We know 7 times 7 is 49, and 49 divided by 7 is equal to 7. Do I divide both of these 7s by 7 like what we talked about with the binomial? No. When you have a monomial or a single term, which a term, remember, can be represented as a product. So you could have multiple things being multiplied. Only one of those gets divided by the number. So 7 times 7 is 49. 49 divided by 7 is 7. Or we could just say this 7 and this 7 crosses out, divides out to give me 1. And then anything times 1 is itself, so that would still be 7. How can we then apply that here? Well, we can cross out, if this is 21 divided by 21 times 7 plus 7 times 21, but we know each term in the binomial has to get divided by 7, then we're going to be able to cancel out the 7 only because it's in both terms, leaving me with 21 plus 21. Let's apply this to what we know about polynomials. Remember, with the division property, if you have the same base, you keep the base and subtract the exponents. So we know x divided by x, anything divided by itself is 1. X to the first divided by x to the first is x to the 1 minus 1, which is x to the 0, which we also know is always equal to 1. Applying that, when you have the same base, keep the base, subtract the exponents. If you don't see an exponent, we know that the exponent is 1. So x squared divided by x is x to the 2 minus 1, or x to the 1, which is just x. Which should make sense. If we go back and apply any number for x there, we should see that makes sense. That's the 7 times 7 is 7 squared divided by 7. Well, if I'm multiplying 7 times 7 and then dividing by a 7, that's the same thing as just dividing out 1 7, and I'm left with 7. Except we now know that pattern works for any number. So again, the division property of exponents, the shortcut is to just, if they have the same base, keep the base and subtract the exponents. So x to the 10th power divided by x to the 2nd power is x to the 10 minus 2, which is x to the 8. It's going to get a little bit more challenging with your polynomials, but it all comes down to you've got the coefficients, and then you've got the variables with like bases, and you're going to actually divide your normal numbers, the coefficients, and subtract the exponents when they have a like base. So I know this answer is 10 divided by 2, which is 5, and x to the 10th divided by x squared, which is x to the 10 minus 2, so x to the 8th, 5x to the 8th. We just divided a monomial by a monomial. We can also apply that when there are multiple terms, as long as we make sure and we divide each term by that monomial in the denominator. So we can separate that and say we've got to do the 4x cubed divided by 2x. And we have to do the 6x cubed divided by 2x. And we have to do the negative 8x divided by 2x. So each term gets divided by the denominator. You divide the normal coefficients. So I can go through here and say 4 divided by 2 is 2, 6 divided by 2 is 3, negative 8 divided by 2 is negative 4. So I know what my coefficients are by dividing. And then when I'm doing my variables, keep the base and subtract the exponents. Where I don't see an exponent, go ahead and fill in a 1. So x to the 3rd divided by x to the 1st, 3 minus 1 is 2, so x to the 2nd. X to the squared divided by x to the 1st, 2 minus 1 is 1, so x to the 1st. And then x to the 1st divided by x to the 1st is x to the 0, which we know is 1. Anything divided by itself will cancel out. So we can also apply that when we have multiple variables by following the rule, as long as they have the same base, keep the base, subtract the exponent. So just knowing that I divide both terms by 2xy, both terms get divided by 2xy. 4 divided by 2 is 2. 12 divided by 2 is 6. Now for the exponents, keep the base, subtract the exponents. So the x is going to be 6 minus 1, which is 5. And the y is going to be 4 minus 1, which is 3. Then on this side, I've got x to the 3rd divided by x to the 1. 3 minus 1 is 2. And then x to the 2 divided by y to the 1. 2 minus 1 is 1. So I've divided to get my answer by dividing each term by 2xy.